beautiful lovers of nature, let's talk about the carbon cycle. Very important. All right, we're going to start with the carbon cycle in the atmosphere. So we know we've got lots of CO2 up here, which is how it's stored in the atmosphere. Now we know that through photosynthesis, this CO2 is going to be turned into biomass. So thanks to all of our terrestrial producers as well as our aquatic producers, we're going to take a lot of CO2 that's in the atmosphere and we're going to turn it into biomass, plant biomass. Now, some of that will be respired back out. So all things, humans, animals, plants, even organisms in our oceans, algae, all go through respiration and decomposition. And both these are going to release the CO2 back into our atmosphere. So it's going to come in through our photosynthesis, but unfortunately respiration and decomposition are going to take it back out. Great. Awesome. Now let's talk about some of the diffusion that's happening at sea level. So at our sea level, we have CO2 that is coming in and dissolving in the water, in the ocean, and then also some of that dissolved CO2 that's coming back out as CO2. Those of you who are in chemistry, especially AP chemistry, this is what we like to call an equilibrium right here. So the same amount of CO2 that's coming in is the same as the CO2 that's coming out. So we're in just a state of equilibrium here where CO2 is diffusing in and out of our oceans. Now let's talk about biomass. After all of our organic material in the oceans and in a terrestrial, once it dies and it head down to the bottom and over so much time and so much pressure, we're going to get this limestone deposits in this dolomite that we can then use as fossil fuels. All right, so we have a combination of both sources and sinks because this cycle is going to move the carbon atoms between our sources and our sinks. Sources are an area where the carbon is going to originate from. The sinks are areas where the carbon can be stored, also known as a reservoir. We talked about this before. And just a reminder, this is a biogeochemical cycle, just along with the nitrogen cycle and the phosphorus cycle. Two main movements, though, that we need to remember. These two, photosynthesis and respiration, also known as decomposition. All right, let's talk about photosynthesis real fast. This is the process where we're going to take CO2 and water, and we're going to turn it into a sugar. This is our carbon sugar and some oxygen. This carbon here is then stored in the plant, creating that biomass. Plants and algae are our primary producers, and they're going to be the primary ones doing our photosynthesis. Algae does about 40 to 60% of it. Pretty impressive. Now the complete opposite. So if I take this whole reaction, I flip it, that's how I get respiration. So respiration is the process of burning a sugar molecule with oxygen to produce CO2 and H2O. Most importantly, respiration is happening with all organisms, animals, fungi, bacteria, and even plants. Don't think that respiration is only happening from our consumers. No, it's also happening from our producers as well. So the CO2 is released, comes back into photosynthesis, and the cycle continues. Now, when I compare these two, respiration and combustion of gasoline, or this would be plant matter. So anytime we use the word combustion, we're talking about burning. And when we mention plant matter, this is pretty much wood. Or it could be substances derived from that plant matter, which could be coal, oil, or gas. Pretty much our fossil fuels. Very, very chemically similar process. In respiration, we're taking glucose. In combustion, we're just taking a carbon hydrogen compound. We call this thing a hydrocarbon. Hydrocarbon. So we're going to take a hydrocarbon, which is either plant matter or derived of plant matter. We're going to burn it with oxygen, and we're going to produce CO2 and H2O and some energy along the way. Let's talk about these carbon reservoirs. We have some short-term ones and we have some long-term. When we're talking about short-term, we're actually talking about the atmosphere. There's not a ton that stays in there. That respiration photosynthesis cycle is very fast. So this is a very quick transfer of CO2. We may have a lot of CO2 in the atmosphere, but that individual CO2 molecule is not going to be in the atmosphere very long. Oceans are another one because, as I mentioned, we have the equilibrium going on, and then also the biosphere. Long-term reservoirs are going to be our rocks, our fossils, and our fossil fuel. For millions of years, these carbon atoms have been stuck in the rocks, the fossils, and the fossil fuels. Now, I just want to mention this real fast. So deforestation is going to add to the carbon cycle because we have less of a reservoir for the carbon to be stored. So when I say that, I mean there's less plants available to take in that CO2 and store the carbon. We can manage it, though. We have found out ways to manage it. However, burning fossil fuels are going to add more carbon into the atmosphere, into the ecosystem, which we have not been able to manage. And that's going to lead to climate change. All right, let's also just quickly remind ourselves what good old bacteria and fungi do. When all things die, these guys are going to extract the carbon. They're going to pull that carbon from that biomass and then return it back into the atmosphere. So very important what these guys do. They're going to return this carbon back into our atmosphere. Okay, so just as a reminder of how do we create this plant matter from the carbon. So my CO2 comes in through photosynthesis. Some of it is respired out. So then the leftover carbon is going to be trapped as cellulose and starch. And we talked about this before with our NPP and our GPP. And so it is using that CO2, that carbon, to build itself up. This missing carbon is now trapped in the plant, and we are going to call that a carbon sink. So a great example of carbon sinks are going to be plants. Here's a tree here. This tree is a 500-year-old carbon sink. It has been containing carbon molecules that were extracted from the atmosphere 500 years ago, and they're still inside this tree. This is a great example of a good sink for carbon. Now let's talk about coal. Coals form when those trees die because they have all that carbon in them. More importantly, though, when they die in low oxygen swamp water. They're going to be buried under sediments that heat and pressure turn these into coal. These are all called fossil fuels. Coal, oil, natural gas, all fossil fuels. Because they contain these carbon compounds, most of it from the sugars produced in photosynthesis. So millions of years ago, all these trees existed in swamps. They died, and through all this heat and pressure, we now have coal. Now, oil and gas are different. Oil and gas are formed due to plankton in the ocean. So this has been, again, over millions of years. Heat and pressure has converted this dead plankton into oil and gas. So you can see it died, and this layer has more and more and more has been built on top of it, creating that oil. Now, we have to remember that most of the Earth's CO2 is in the ocean. It's going to move in and out through diffusion. CO2 is more soluble in cold water than warm water. So it's going to we're going to get more CO2 in the poles than we are near the equator. That's a lot of chemistry. So if you're unsure about that, please come ask me. I'm happy to help with that one. It has to do with solubility and temperature. Now, when the CO2 comes in, it's going to form carbonic acid. I want you to circle this carbonic acid because it's going to be very important when we start talking about the impacts of the CO2 in the oceans. For example, many marine species, so mollusks, coral, zooplankton, they build their shells out of calcium carbonate, this guy here, by combining the Ca plus 2 with the CO3 minus 2. However, though, over time, we're getting so many dead organisms, and they're slowly turning into a type of rock called limestone. Once this carbon becomes limestone, it's not going to return to the atmosphere for millions of years. Apart from the atmosphere, some other reserves that we have are seawater, one of our largest, soils because of all the decomposing plant matter inside, forests, coal, oil, natural gas, and limestone. Now, just to put this all into perspective, okay? I just want to kind of sum it up here. When you eat fruit, you are respiring and releasing carbon that was stored in the plant tissue earlier that season. When wood is burned, it's releasing carbon that was stored, maybe a decade or a century ago. When fossil fuels are burned, they're releasing carbon that was stored for millions of years. And when volcanoes erupt, they release carbon that has been stored in limestone for tens of hundreds of millions of years. So just to give you perspective on where your carbon is coming from. All right, other resources if you need it. That's a wrap. We'll see you later.